Okay, so greetings to everyone. Welcome to CAP Engineering Video Tutorials. Okay, so ang subject natin ngayon is Geotechnical Engineering. Ito yung ating Module 2, Part 1. Okay, wherein yung iti-take up natin na topic is yung consistency in soil. Okay, pag sinabi natin consistency in soil, dito na dito matitake up yung topic na Atterberg Limits. Okay? So, let's start na, no? Okay, so, consistency of fine-grained soils. Okay, pag sinabi natin fine-grained soils is yung, from the word fine, talagang pinong-pino yung grano niya ng soil. Okay, like clay and salt. Okay, yun yung mga fine-grained soils. Okay, so, consistency is a term used to indicate the degree of firmness. Example, soft, medium, stiff, or hard of cohesive soils. The consistency of soil is greatly affected by the water content of the soil. Okay, so pag sinabi nating Atterberg Limits, no, para maintindihan talaga, i-explain ko sa inyo kung anong concept niya. Okay, so ito yung concept niya, class. Okay, so magsample lang tayo na magsample lang tayo na meron tayong soil. Okay, ito yung natural state ng soil natin. Wherein yung state ng natural yung natural state ng soil natin is in liquid state. Or meaning assume lang tayo na yung soil na to is saturated. And then nilagay natin siya sa isang dish. Okay, ang gawin natin, class, is ilagay natin siya sa oven. Okay? And then i-dry natin siya in a certain time. Okay? In a certain given of time. And then, class, anong mangyayari kung i-dry siya? Okay? Alam natin kapag dinadry natin is mawawalan yung tubig. Okay? Mawawalan yung tubig na nandito sa soil. Okay? Okay, yun lang ba yung nawala or may changes pa? Okay, itong mangyayari, class. Tingnan nyo yung figure na to. Okay, tingnan nyo yung figure na to. Itong mangyayari, class. Okay, so soil path after drying, okay, ito na yung bagong soil niya, class. Okay? So meaning, yung volume initial niya, class, is not equal to the volume final. Meaning, there is a change in volume during drying. Therefore, there is shrinkage occur. Okay, gets nyo, class? Okay, kapag yung tubig mawala, okay, yung volume niya is ma-change rin or ma-decrease, mas-shrink siya with respect to the moisture content na nawala sa soil. Okay? Okay, ito yun. So, ito yung ating soil path before drying, and then after drying, class, ito na yun. Soil path after drying. Okay, talagang wala ng tubig matitira dito. Okay? And then, class, para maintindihan natin, dapat natin i-graph yan, no? Ito yung graph natin, class. Okay? So, in vertical, mag-assume lang tayo, ito yung ating vertical axis, that is represent the volume of the soil. Okay? Ito yung volume natin. And ito yung volume niya after drying. Okay? And then in horizontal, class, in horizontal axis, that is represent the moisture content of the soil. Okay? So, ang gawin natin, class, ipa-plot lang natin siya. Okay? Ganito, class, no? Di ba sinabi ko, class, ito yung ating natural moisture content, natural state of soil. At sinabi ko rin na yung moisture content niya is in liquid state. Okay? And then, class, may apat na state tayo. Okay? So, solid state, semi-solid state, plastic state, liquid state. Okay? Pag sinabi nating liquid state, class, okay, yung soil niya, class, is magpo-flow like a viscous fluid. Okay? So, i-imagine nyo, class, no? Yung soil is inclined. Kapag magpo-flow yan, class, like fluid, okay? That soil is in liquid state. Okay? Pag sinabi nating plastic state, class, okay? Ito yung soil niya, class. Okay? Ang soil na, class, can be remolded in any shape. Okay? without visible cracks. Okay, walang cracks na makikita dito, class. Okay, so ma-change yung shape niya or volume, pero yung walang visible crack na makikita. Okay, yun yung plastic state. Okay, how about yung semi-solid state, class? Kapag sinabi natin semi-solid state, class, okay, ito yung magdi-decrease yung shape niya. Okay, any further change in shape ng semi-solid state, okay, makikita niya yung visible cracks. Okay, so semi-solid, makikita yung crack. Plastic state is walang makikitang crack. Okay, kapag sinabi natin solid, talagang solid lang siya, no? Solid state lang siya. Okay, so ito yung class. Okay, ipa-plot lang natin yung moisture content niya. Okay, okay, yung moisture content niya is ito at plastic state. Okay, assume lang natin na ito yung plot natin at A. Okay, initially, class, ito yung ating, okay, di ba ito yung ating volume initial? That is our volume initial. So therefore, this is our volume initial also, class. This is the volume initial. Okay? Pag sinabi natin, kapag completely dry na siya, class, ito yon. Okay, dito na siya, class. Talagang wala ng tubig matitira dyan. Okay, kapag wala ng tubig matitira dyan, class, yung moisture content niya is 0. Okay, di ba moisture content is equal to the weight of water divided by the weight of solids. Okay, kapag wala ng water dyan, class, this is 0. Okay, therefore, moisture content is also 0. Okay, so completely dry, dito siya, class. Ito yung ating volume final. Okay, so ito yung ating volume final, class. Ito yan, dito yan. Itong height na yan, class. Okay, so ipa-plot ko lang, class, no? Okay, so ito yon, moisture content. Okay, initially, class, kapag nilagay natin siya sa oven, and then i-dry natin siya, class. Okay, ito yon. Okay, kapag dry natin siya, okay, kapag umabot na siya, class, at point B, okay, dito yung moisture content niya, class, at point B, okay, tinawag natin ito na liquid limit. Okay, so liquid limit is the moisture content of the soil in which soil grains are separated by water, just enough for the soil mass to lose shear strength. Okay, kasi kapag liquid state, class, walang shear strength dito. Pero yung plastic state is meron. Okay, yun yung kanya, class. Yun yung meaning nito. Okay? And then, how about, class, kung i-further drying ko to? Okay, ito mangyayari naman. Okay, i-further drying ko siya. And then, pag umabot siya at point C, yung moisture content niya, class, okay, at point C, tinatawag natin siyang plastic limit or denoted natin siya as PL. Or plastic limit is the water content in which the soil will pass from the plastic state to semi-solid state. Okay, di ba maintindihan natin to? Okay, from plastic state to semi-solid state. Okay, yung interface nila, yun yung plastic limit. Okay, soil can no longer behave as plastic. Okay, any change in shape will cause the soil to show visible cracks. Okay, kapag ito yung plastic limit natin, kapag yung moisture content mo is mas mababa pa sa plastic limit, doon na yung makikita yung mga visible crack niya. Okay, so meaning at plastic limit is dito makikita yung impending cracks niya. Okay, how about, class, kung i-further drying ko pa to? Okay, anong mangyayari? Okay, ito yung mangyayari, class. So papunta siya at point D. Yung moisture content niya, class, at point D is ito yung tinatawag nating shrinkage limit or denoted natin siya as SL. Or shrinkage limit is the water content in which the soil is no longer changes in volume regardless of further drying. Okay? Kapag umabot na siya at sa shrinkage limit, class, okay, talaga yun na yung maximum volume niya. 'Di ba? Minimum volume na na meet niya, class? 'Di ba ito 'yon? 'Di ba ito yung volume final natin? Okay, ang volume niya at point D, class, is equal to this one. Okay, ang pagkaiba lang, class, okay, kapag yung moisture content niya is at shrinkage limit pa, okay, yung soil dito at shrinkage limit is saturated soil. Okay, saturated soil ito. Okay, di ba sinabi, any lower than the shrinkage limit will cause the water to be partially saturated. Okay, kapag further drying ko pa to, okay, wherein there is a decrease in moisture content, okay, kasi decreasing yung moisture content niya, na? So, therefore, partially saturated na siya. Okay, pero at shrinkage limit, saturated, talagang fully saturated siya. Okay? Yun, class, no? And then, how about, class, kung further drying ko pa to? Okay, so dito na may meet yung oven-dried soil. Okay, completely oven-dried soil. Okay, talagang wala ng tubig matitira dito, class. Kasi yung moisture content niya dito, class, is 0. Okay? Pero yung volume ng soil dito, class, is ito yon. Okay? Yun, class. Pero wala ng tubig dito. Kapag yung moisture content mo is 0. Okay? Kuha ko, class? No? Kuha ko? Okay? Okay, so may tinatawag tayo na soil indices, no? May 4 ito, class. Okay? So, una is may tinatawag tayo na Plasticity Index, or PI. The difference between the liquid limit and the plastic limit of a soil which define the range of the water content over which the soil deforms plastically. It is always expressed in percent. Okay? Yung Plasticity Index, class, is yung range nito. Yung from liquid limit to plastic limit. Yung range na, class. Okay, how to determine that range? That is, PI is equal to liquid limit minus plastic limit. So, minus this one minus that one. And that is represent the plasticity index of the soil. Okay, nakuha ko, class? Kasi sinabi dito, range of water content over which the soil deforms plastically. Okay, ito yung plastic deformation niya, class. Dito nangyari. Okay, nakuha ko? Okay, so second, class, may tinatawag tayo na liquidity index. Okay, so liquidity index is the ratio in the moisture content between the natural or in situ water content of the soil and its plastic limits to its plasticity index. So, moisture content minus plastic limit. Okay, ito yung, class, dito yan, ito yan. Itong range na yan, okay, that is represent to this one, minus plasticity index, minus this range, class. Okay, and that ratio, class, that is represent the liquidity index of the soil. Okay, take note, class, no? Kuwan dito, may rules dito, class. Kapag yung liquidity index mo, class, is less than 0, okay, yung state ng soil, class, is semi-solid. Okay, tandaan nyo, kapag liquidity index is less than 0, please, semi-solid state, yan. Okay, kapag yung liquidity index, class, is between 0 and 1, or, like this one, class, okay, like this, hindi na ako inequality tayo, class, no? Okay, ito yung, class, no? Okay, kapag yung range natin, class, is between from 0 to 1, okay, yung state ng soil, class, in plastic state. Okay, tandaan nyo yung, class. Okay, kapag naman yung liquidity index is greater than 1, okay, yung state ng soil, class, in liquid state. Okay? So, therefore, the liquidity index, class, it can be used to determine whether it's what types of state yung soil natin. Okay? Nakuha ko, class? Okay? So, next is may tinatawag tayo na Shrinkage Index, or denoted natin siya as SI. No? The range of water content from plastic limit to the shrinkage limit is called the Shrinkage Index, or SI. Itong range na ito, class, no? Itong range na to. From plastic limit to shrinkage limit. Ang tawag dyan, class, is Shrinkage Index. Yung range na yan. Okay? PL minus SL. Okay? Pangapat is may tinatawag na tayo na Consistency Index, or denoted natin siya as CI. Okay, so the Consistency Index is defined as CI is equal to liquid limit minus moisture content divided by liquid limit minus plasticity index. Or it can be in this formula, class, no? Liquid limit minus moisture content, okay, divided by the plastic limit. Okay, kasi class, ito yung class, liquid limit minus plasticity index, that is represent the plastic limit of the soil. Okay, kuha nyo. Next is, in determine the liquid limit of the soil, class, may liquid limit test tayo na ikakandak. Okay, so there are 3 methods in determining the liquid limit of the soil. Okay, una, class, is may tinatawag tayo na Casagrande Cup method. Okay, so from the word cup method, class, ito yon. Okay, ito yung Casagrande Cup method, class. Okay, so ina-advise ko talaga kayo na mag-watch kayo sa YouTube ng experiment na to. Okay, may experiment sa YouTube, class, is watch lang kayo doon. Okay, i-search lang. Okay, maraming doon, class. Okay, explain ko lang ng konti kung anong mangyayari dito, class, no? Okay, so ito, class, is may soil paste na ilalagay dito. Okay, may soil sample na ilalagay dito, class. And then itong groove na to, class, is makagagamitin yan para makakreate ng open line or separation. Okay, separation between two soils na separate natin. And then ang gawin niya, class, is ika-crank niya, paikutin nyo ito yung crank na to. Okay, kapag umikot yung crank, class, okay, yung brass cap nito is it will goes up and down. Okay, it will goes up and down. Okay, kapag yung cup brass brass cap, class, is nag-touch hard rubber, tumutunog yun. Okay, pak pak pak, yun. Okay, kapag isang touch, class, that is represent one blow. Okay, one blow, class. Okay, so experiment na to, class, is ito yon, is may target siya kung anong blows na gagamitin sa isang test. And then kapag na-meet na yung number of crank, is ita-transfer ito into a container, and then i-dry siya, class, para makuha yung moisture content. And another test naman, okay, class, is with the same method. Okay, and then, class, and then makukuha yung liquid limit ng soil, class, is by graphical method. Okay, by graphical method. Okay, kapag makukuha, class, yung liquid limit kapag yung moisture content niya is represent the 25 blows, class. Okay, kapag 25 blows, class, that represent the liquid limit of the soil. Okay, yun lang yung tandaan natin dito. Okay, pangalawa, class, is may tinatawag tayo na Falcon method. Okay, so ito yung, class, itong picture na to, itong apparatus na to, class. Okay, it will goes up and down. Okay, so itong cone na to, class, ito yung ginagamit natin, ito initially at ito an after. Okay, initially, class, is wherein top lang siya at the surface of the soil, and then dito, class, is ipa-fall yung cone natin. And then actually may reading dito, class, may reading dito. And then sa reading niya, class, is mariread niya yung penetration. Okay, penetration. And then this test class can be conducted minimum from 4 tests and above. Okay? I think hindi ako sure sa 4 or 3 or 4. Okay? But basta yun class. Okay? And then class, kapag sinabi natin Falcon method to determine the liquid limit of the soil, yung weight ng cone niya na ginamit is 0.78 Newton. Okay? Kapag yung penetration mo is equivalent to 20 mm, that is represent the liquid limit of the soil. Okay? Tandaan nyo class, kapag sa grande cap, 25 blows. Okay, kapag Falcon method, yung penetration niya is 20 mm. Okay, pangatlo is may tinatawag tayo na 1-point method. Okay, yung 1-point method class is actually hindi na to ginagamit class, no? Okay, kasi yung 1-point method is talagang formula based ito. Okay, talagang may formula based lang siya. Okay, or empirical formula na gagamitin. Okay, itong 1-point class is hindi na ko to i-explain for this sa inyo. Okay, ito lang dalawa ito. Casagrande Cap method at Falcon method. Okay? So, yun lang yung i-discuss ko. Okay, so in plastic limit test class, there are two methods in determining the plastic limit of the soil. First is by rolling, no? Rolling a soil mass on a ground glass plate. Okay, ito yung class, no? Ito yun. Okay, the plastic limit is defined as the moisture content in percent, which is the lower limit of the plastic stage of soil. The plastic limit is determined by rolling a small clay sample into threads and finding the water content, and which threads approximately 3 mm in diameter will just start to crumble. 2 or more determinations are made, and the average water content is reported as plastic limit. Okay? So, class, ito yun. Kukuha ito ng isang kunting sample of soil, and then mag-create siya ng pataas na pabilog yung cross-section niya, at iro-roll niya ito, class. Okay? Iro-roll niya ito. Okay? Kapag nagsimula na itong mag-crumble, class, kapag mag-crumble na siya, or yung mag-start na siya, makita na yung mga crack niya, is yun na yung plastic limit ng soil. Diba kapag plastic limit, yun yung pag-start na yung crack is visible. Diba sinabi ko na yun, sinabi ko na doon sa previous slides. Okay? So, and then plus, kapag nakita na yung visible crack, is i-transfer ito into a container, and then ilagay sa oven para makuha niyo yung moisture content niya. Okay? And then, kailangan talaga class 2 or more determination. Okay? Kailangan 2 or more tests nga ikakandak niya. Okay? To solve that plastic limit. And the average water content class is yun yung ating plastic limit. Okay? Average lang. Okay? Kung dalawang test lang niya, okay? So, test moisture content on 1 plus moisture content on 2 is divided by 2. That represents the plastic limit of the soil. Okay? So, pangalawa class is Falcon method. Okay? Pwede rin gamitin in plastic limit test. Okay? Alam natin yung Falcon method class. Okay? Same apparatus lang. Pero, ang difference lang niya class is, as in the case in liquid limit determination, the Falcon method can be used to obtain the plastic limit. This can be achieved by using a cone of similar geometry but with a mass of 2.35 Newton. Diba, kapag liquid limit test, yung ginamit niya is 0.78 Newton. Okay, pero kapag sinabing plastic limit test is 2.35 Newton. Okay, so 3 to 4 tests at varying moisture content of soil are conducted, and the corresponding cone penetration are determined. The moisture content corresponding to a cone penetration D is equal to 20 mm is the plastic limit. So, same lang din yung criteria class. Okay, kapag yung penetration niya is 20 mm, that represent the plastic limit. Same with the liquid limit test. Okay? Ang pagkaiba lang niya ang yung cone na ginamit class. Okay? So, mag-sample problem na tayo, no? Okay, so sample problem 2.1. The following data were obtained from the Atterberg Limits test for the soil. Okay, so liquid limit is equal to 41%. Plastic limit is equal to 21.1%. A is what is the plasticity index of the soil. B is if the NC2 moisture content of the soil is 30%. What is the liquidity index of the soil? C is what would be the nature of the soil. Okay, so A tayo una, class. Okay, pag sinabi natin plasticity index or PI, PI is equal to liquid limit minus plastic limit. That is the range. Okay? Okay, so liquid limit is 41%. So 41 minus 21.1%. Okay, so therefore PI is equivalent to 19.9%. And that will be our answer in A. Okay? So in B class, okay, so ito yung ating liquidity index. Li is equal to moisture content minus plastic limit divided by liquid limit minus plastic limit. Okay? And then class, kapag sinabi natin NC2, okay, from the word NC2 class, yung meaning na NC2 is natural. Okay, natural moisture content. Meaning, ito yung natural moisture content natin. Which is yung natural moisture content natin class is 30%. Okay, so what is the liquidity index of the soil? Okay, so meron na tayo moisture content, plastic limit, meron na tayo 21.1, liquid limit, meron na tayo 41%. So therefore, we can directly solve the liquidity index of the soil. And that is, okay, so 30 minus 21.1 divided by 41 minus 21.1, that is equivalent to 0.447. And that is our liquidity index of the soil. Okay? So, kuha nyo? How about C class? Okay, so what would be the nature of the soil? Pag sinabing nature of the soil class, is tinatanong dito is what is the state? Or what is the state of the soil? Okay, so to determine the state of the soil, kailangan natin yung liquidity index niya. Okay, since yung liquidity index is the determinant natin at na alam natin na 0.447, and since yung liquidity index natin is between 0 and 1. Okay, so ito yon. Okay, kapag between 0 and 1 class, that is, the soil is said to be plastic state. Okay, gets nyo class? Okay, so next problem tayo, no? Okay, so problem 2.2. The following data shows the result of the liquid limit and the plastic limit test. Okay, so meron tayong data dito class, no? Isang table lang. Yung A natin is ito yung ating data ng pag-determine ng liquid limit. Okay? Yung B natin class is ginamit for plastic limit and natural water content test. Okay, so ito yung plastic limit test at ito yung ating natural water content test. Okay, so in determine the liquid limit test class is may test number siya. Okay, so ito yung ating test number 1, ito yung ating test number 2, at ito yung ating test number 3, at ito yung ating test number 4. Okay, so dito rin class is number of blows yung ginamit niya. Okay, so test number 1, that is 39, test 2 is 23, test 3 is 20, test 4 is 13. Okay, like I said class, okay, in every blows class is dinidetermine yung moisture content ng soil. Okay, so weight of wet soil plus container is tinitimbang class is ungiven niya dito. Okay, in every respective test class may data na. Okay, so weight ng dry of soil is tinitimbang yung class. Okay, ito yung class kasi. Okay, kapag na-meet na yung number of blows, ita-transfer siya into a container and then ititimbang siya class. Okay, ito yung weight niya. Itong weight na to class. And then ilalagay siya into oven class. Okay, after yung soil natin is completely over-dried, is ititimbang ulit yon. At itong data na yon is ito yung data na yon. Okay? And then yung weight ng container class is initially before i-transfer yung soil sample class is ititimbang muna siya. And that is the data class. Okay, that is the data with respect to the task number. Okay, nakuha niyo ako? Okay, so compute, ito yung tanong natin class. Compute the liquid limit of the soil sample. Okay, use graph in figure P1.33. Okay, so gagamitin natin itong graph na to, class, to determine the liquid limit of the soil. Okay, so B is compute the plastic limit. Okay, ito yung gamitin natin. Dito tayo magsimula sa data na to. C is compute the plasticity index. Okay, D is compute the liquidity index of the soil. Okay, so unahin natin solving sa A, class, the liquid limit of soil. Okay, so yung unang gawin natin, class, is i-determine lang natin yung muna natin yung moisture content with respect to the test number niya. Okay, so test number 1, yung sample 1 natin, class, is anong moisture content niya. And test number 2, kunin natin yung moisture content. Test number 3, kunin natin yung moisture content. And also number 4. Okay, and then i-graph natin siya, class. Okay, kasi may graph dito, class. Ito yung vertical is ito yung ating moisture content, and yung horizontal, class, is the number of blows. Okay, para mag-graph natin, class, kailangan natin yung moisture content with respect to the number of blows ng soil. Okay, so ang gawin natin, class, is ito yung gawin ko. Okay, mag-create lang ako ng table, class, no? Para ma-visualize natin ng maigi. Okay? So, itong column na to, class, itong gray na to, ito yung column na in-add ko. Okay? Wherein, ilalagay ko dito, class, is, by the way, class, in determining the moisture content of the soil, okay, so moisture content is equal to weight of water divided by weight of solids. Okay? Or, it can be weight ng moist minus weight ng solids or dry divided by weight ng solids or dry. Okay? Pero ito gamitin lang natin, class, no? Para maiksi solution natin. Okay? Kunin lang natin yung weight ng water at kunin natin yung weight ng solids. And then, i-divide natin, class, and then times 100, that is represent the moisture content of the soil. Okay? So, therefore, class, okay, so, weight of water in grams, ito yung akong first column na in-add ko. And then, weight ng dry soil in grams. And then, moisture content in percent. Okay, so how to compute the weight of water in grams, class? Okay, di ba sinabi natin, weight of moist minus weight of dry. Okay, di ba ito yung ating weight of wet soil and ito yung ating weight of dry soil. And then, ito yung weight na to is, nag-add on na yung container and also the weight of dry soil. Okay, kapag sinubtract natin itong dalawa, class, ito yung weight of wet soil and container and weight of dry soil and container, yung matitira, class, is only the weight of the water. Okay, gets niya? So, to compute the weight of water in grams, that is 22.24 minus 19.44. Okay, and that is equal to 2.8. Okay, kuha niyo ako, class? Okay, kailangan maintindihan nyo ito. Okay, how about, kunin natin si weight of dry soil. Okay, para makuha natin yung weight of dry soil, class, so, i-minus natin ito, class. So, 19.44 minus weight ng container, minus 12.74. And that is equal to 6.7. Okay, itong data na to, class. Okay, itong data na to, and minus natin dyan, para makuha natin yung weight ng dry soil. Okay, pero, to determine the weight of water, ito na, class, itong weight na to, plus, minus lang natin directly ng weight na to. And that is represent the weight of water. Okay, nakuha niyo ako, class? Okay? Okay, so 6.7. How to compute the moisture content? Okay, so calculator muna ako, class, no? Okay, so, okay, so there, 2.8 divided by 6.7 times lang ako ng 100 to make 8%, and that is 41.71%. So therefore 41.79% to. Okay, so wala na percent kasi percent na to dito. Okay, nakuha niyo ako? So test number 2 naman tayo, class. Okay, so in test number 2, so 21.19 minus 18.78, that is 2.41 grams. Okay? Wait lang sa... Okay, so how to determine the weight of dry soil? So 18.78 minus 13.24, that is the weight of the dry soil, and that is equal to 5.54. Okay? To determine the moisture content, so 2.41 divided by 5.54 times 100, that is equal to 43.50%. Okay? So, in test number 3, so weight of water, that is 21.27 minus 18.78, and that is equal to 2.52. Okay, to determine the weight of the dry soil, that is 18.75 grams minus 13.06 grams, and that is equal to 5.69 grams. Okay, to solve the moisture content, so 2.52 divided by 5.69 times 100, that is our moisture content, which is equivalent to 44.29%. Okay, so test number 4 na tayo. Okay, so weight of water, okay, that is 26.12 minus 22.10, that is 4.02 grams. And then weight of dry soil is equal to 22.1 divided minus 13.27, that is 8.83 grams. Okay, so to determine the moisture content, that is 4.02 divided by 8.83 times 100, and that is equal to 45.53%. Okay, so in every respective lows class is my respective moisture content na tayo. Okay? So therefore, we can use the graphical class. Okay? So using graph class, i-graph lang natin to. Okay? So liquid limit, okay? 'Di ba sinabi ko class, liquid limit is at 25 lows. Okay? So ito yung ating i-determine yung moisture content ng 25 lows para ma-determine natin yung liquid limit natin. Okay, so using the graph class, ito yung graph natin. Okay, by the way class, careful kayo dito, no? Kasi yung x direction niya, ito yung number of lows, logarithmic scale yung class. Okay, hindi yan even distribution of value. That is logarithmic. Okay? Example ng class, ito from 10 to 20. Okay? Kung 10 to 20 class, kung hahatiin ko siya into 10, okay, itong 10 to 20 class, palakihin lang ko lang yan. Okay? Ito yung example lang class, ito yung ating 10. That is simple lang class. That is 10 and 20. Sample lang class, ito yung ating 20. Okay? We're in this distance class, palalakihin ko lang. Okay, para ma-visualize natin. Okay, anong notice nyo? From 10 to 20, ang gap niya is 10. And 20 to 30, that is 10 also, yung gap natin. And then 30 to 40, ang gap niya is 10 also. Okay, so anong nanonotice natin? So, kapag lumalayo siya class, okay, yung every part niya class is umiiksi. Okay, umiiksi siya. Okay, kasi hindi ito linear class, hindi linear distribution. Ito is logarithmic. Okay, kailangan careful kayo dito. Okay, actually class, wala namang exact value din naman dito kasi approximate lang yung ginagamit natin. Okay, wala, akong ulitin ko lang, walang exact value dito. Yung i-determine sa atin, yung nearest value lang. Okay? So, at 39, unahin natin yung class, yung 39 blows. At saan yung 39 blows class? Dito yung 39 blows class. Oh. Nandito yung 39 blows. And yung moisture content niya class is 41.75. Okay? 41.7, that is nearly 42. Okay? So, assume ko lang, nandito yung graph class. Oh. Ito yung ating point ng task number 1. Yung task number 2 natin class is 23 blows. Ito yung represent ng 23 blows. Okay, ito yung ating 23 blows ito class. That is 23 blows. Okay, ito yung ating 23. Okay, and then moisture content na class is nandito. Okay, ito yung moisture content. Magkano mo moisture content? 43.5. Okay, dito yung class. How about yung test number 3 natin class, 20 blows. Okay, so 20 blows, okay, may clue tayo class, nandyan. Okay, how about yung moisture content? Yan. Okay, so nandito class, oh, nandito yan. Okay, dito. How much yan class? 44.29%. How about test number 4? Ito yung ating test number 4. And then yung number of blows niya class is 13. Ito yung 13 natin. And then, yung moisture content niya is 45.53. Okay? Above ng konti class ng 45%. Okay? Ang gawin natin class is, mag-assume lang tayo ng a linear. Mag-draw lang tayo ng a linear line which will best fit for the point of intersection. Ito yung ating mga points class. Okay? So, mag-draw lang tayo ng line class. Itong line na to, okay, that will be the best fit. Okay, that will be the best fit of the graph class na. And then, ang kunin natin class is, yun na yung linear line natin class. And then, kunin natin yung 25 blows. Okay, take note class. Okay, hindi pwede class no, kasi 10 yan, and then, kukuha kayo sa center. Hindi class ha. Hindi class. Kasi, logarithmic scale yan. Okay, yung 25 plus approximately nandito yan. Okay, hindi yan nasa center. Okay, kasi logarithmic yan class. Log scale tayo. Okay? Kuha nyo, no? Okay, so, in 25 plus, okay, kuha nyo. Okay, hindi nasa center yung 25 natin. Okay, nanonotice nyo. So, ito yung 25 25 blows ng graph class. And then, i-reading lang natin ito manually. Okay? Assume lang tayo, ito yung ating 42.5, no? Nandito yung ating 43.5. Actually, nandyan approximately to 43%. Okay? I-reading natin siya class at 43.2%. Okay? A class is, ulitin ko lang, this is only approximation. Okay? Walang exact value dito class. Okay, so there is the nearest value, 43.2%. So that's why class, our liquid limit is 42.2%. Okay, nakuha nyo class? No? Actually class, no, okay, another solution tayo class. No? My best way to determine the liquid limit of the soil class using this table, no? Using this tabulation. Okay, diba yung scale natin class is logarithmic? Okay, balik ko lang. Diba logarithmic yan class? Logarithmic yan. Logarithmic scale yan. Okay, so ang gamitin natin class, gamitin natin yan si calculus. Okay, gamitin natin si calculus. Ito gamitin natin. Okay, gamitin ko lang class. Okay, ang gawin ko, mag-mode stat na class. Mode 3 stat. And then, ang gamitin ko class, yung logarithmic. Okay? Logarithmic or ln class, ito yung ln natin. Ito class, 4. That represent logarithmic. Okay? Yung x natin class is, di ba yung x natin is number of blows. Yung vertical axis natin class is yung percent moisture content. Okay? So, i-input lang natin class. Okay? So, by 39 blows, okay? 39. Okay, input ko lang muna class, 23, 20, okay, ito 20, and then 13, okay, 13, apat yan class, apat, okay, and then, in task number 1 class, in 39 blows, what is the moisture content? 41.79, input ko lang class, no, 41.79%, and then, yung task number 2 class, that is 43. Ito yan, 43.50. Okay, so 43.5 and then equals class and then 44.27. Okay, ito yan, 44.27 equals and then last one is yung 13 blows. Okay, so 45.53%. Okay, so ang gawin ko class is kunin ko yung moisture content or kunin ko yung y at 25x. Okay, so ang gawin ko is 25 and then stat ako and then yung gawin ko is variance and then kunin ko si and hindi pala no hindi dito class shift stat reg pala class reg Okay, kunin natin si Y class, no? So, input natin si Y class 5 tayo. Okay? And that is 43.33% plus. That is 43.33%. So, therefore, our another answer for the liquid limit is equal to 43.33% plus. Ang tanong dito, anong gagamitin ko? Actually, pwede mo gamitin yung dalawang yan class. Okay? Pero yung pag tinatanong tayo kung anong nearest value class, talaga magpe-prevail class yung logarithmic ng calculator. Okay? So therefore, to meet the nearest possible answer, we use this one. We will use this one. Okay, kuha nyo class. Okay, we'll use this one class. Okay, ito yung gamit natin class. Ito lang natin gamitin. Okay lang sa akin yan. Okay, nakuha ko? Nakuha nyo ako class? Okay, so therefore, our final answer for the liquid limit, that is 43.33%. And that is our final answer for A. Okay, so compute the plastic limit. How to compute the plastic limit class? Okay, ito. Okay, so kunin lang natin yung measure content ng yung task number 1 and then kunin lang natin yung measure content ng task number 2. Di ba sinabi na ang plastic limit can be determined by the average of the moisture content. Okay? So, average na natin to. Okay, so ito yung gawin natin class. Same pagkuha natin dito kasi same moisture content na sila. Okay, so weight of water in grams, weight of dry soil in gram, moisture content. Okay, so how to solve the weight of water in grams? Okay, dito class, that is 22.12 minus 20.42. That is the weight of the water and that is equal to 1.7. Okay, how about ng weight of dry soil class? Okay, that is 20.42 minus the weight of the container, which is 13.01, and that is equal to 7.35. Okay, to determine the moisture content, okay, so 1.7 divided by 7.35 times 100, that is 23.13%. Okay, and then task number 2 tayo. So weight of water, that is 21.84 grams minus this one, 20.19, that is equal to 1.65. Okay, to determine the weight of dry soil, that is 20.19 minus 13.18, and that is equal to 7.01 grams. Okay, to solve the moisture content, that is 1.65 divided by 7.01 times 100, that is 23.54%. Okay, so therefore, may moisture content tayo class. Okay, yung task 1 and task number 2. So therefore, the plastic limit is the average of that 1, of that 2. This is 23.13 plus 23.54 and divided by 2. That is our final answer will be 23.34%. And that is the answer class. Okay, how about the compute the plasticity index of the soil or PI class, yung PI pinadidetermine. Kapag sinabi natin plasticity index class PI, alam natin yung PI class is equal to liquid limit minus plastic limit. Okay, by the way class, hindi ito LI class, PL to. Okay, PL to, hindi ko na-edit class ha. Okay, so we have liquid limit class, no? We have liquid limit and we have also plastic limit. So we can directly solve the plasticity index. Okay, so and that is equal to 43.33% minus 23.34%, and that is equal to 20%. Okay, na-get nyo ako class? Okay, so last number tayo class, no? So compute the liquidity index. Okay, so hindi na magkasya class, i-arrange ko lang class. Okay, itong table ng liquid limit test, hindi ko na needed ito class. Okay, kunin ko muna yung natural water content test, no, of soil. Yung natural water content ng soil class is same method with the method of plastic limit test class. Okay, average lang yung dalawang to. Okay, so weight ng water, yung natural water content class, 17.54 minus 14.84, that is equal to 2.69. Okay, and then 14.84 minus 7.84, that is 7. Okay, so 2.69 divided by 7 times 100, that is the moisture content. Okay, so 38.43%. Okay, and then, weight of water in test number 2, that is 2.61, 16.97 minus 14.36, 2.61 is equal to 2.61 yan. Okay, so weight on dry soil, this is 14.36 minus 7.5, and that is equal to 6.86. Okay, so, and then moisture content class is 2.69 divided by 6.86, and this is 38.05%. Okay, hindi na kasya class, is i-move ko lang to. Okay, i-move ko lang siya class, no? Okay, i-move ko lang. Okay, walang nabago dyan class, i-arrange ko lang yan. Okay, so to determine the liquidity index, or denoted natin siya as Li, Li is equal to moisture content minus plastic limit divided by liquid limit minus plastic limit. And we know class na na-determine na natin yung liquid limit at plastic limit. Ito yon class, ito yon at ito yon. Ang kulang na lang class is moisture content. How to determine the moisture content to solve the liquidity index? So moisture content class, to determine that one, that is itong average ng moisture content ng 1 and moisture content ng 2. And that is equal to 38.43, okay, 38.43 plus 38.05 divided by 2. And that is equal to 38.24%. Okay, kuha nyo ako class. So, to determine the liquidity index, so that is equal to 38.24 minus 20 divided by 43.33% minus 23.34%. That is equivalent to 0.745. And that is our final answer, class. Okay, how about kung pinadetermine dito, class, ng state ng soil? Okay, since between 0 and 1 yung class, so therefore, plastic state ito. Okay? So, yun yung class, no? Okay, so the end na tayo, no? Okay, so the end of our part 1. Okay, actually, may part 2 pa dito, class. Okay, so the end of part 1. Thank you for watching, no? The best, good luck, and God bless. Thank you all.